Hey guys, hope everything's going well. Hope you guys figured out 7-1 okay and didn't have many problems with it. For those of you who did, please, hopefully you reached out via email. But anyways, we're going to cover section 7.2 this whole week. We're going to cut it into two sections. So the two quote unquote lessons that we cover a week, it'll be lesson 7.2a and lesson 7.2b. For both of them, I'll post a separate lecture. I'll post two different recordings, one for day one for day two, one for section A, one for section B, whatever way you want to do it. And then you'll also have two different homework assignments via Big Ideas, one 7.2a and one 7.2b. Please note that homework assignments are due Thursday at midnight. Don't get caught up in that. You guys have a whole week to do two assignments. That should not be hard. We've really cut this down as much as we possibly can. All right, so 7.2 part 1, well, 7.2 part 2 as well. We're talking about graphing rational functions. You guys, I've told you several times, the shrink, stretches, reflections, up, down, left, right, all that jazz, it doesn't change. So hopefully a lot of this is review. Some of it will be new as well, especially day 2. You're going to learn a lot of new things. For those of you going on to, well, really either college algebra or pre-calc next year, you will definitely need to know this. So please pay close attention. Please take notes as I lecture, and then follow those notes as you do your homework. All right. So the parent function of rational functions is f of x equals 1 over x, guys, and it looks like this, okay? It's called a hyperbola. Now, the reason it's called a hyperbola is because it's cut into two parts. So we have this part here in the first quadrant, and then we have a part here in the third quadrant. Now, hyperbolas are always in opposite quadrants, so it'll either be in quadrants 1 and 3, or it'll be in quadrants 2 and 4. Once you get shifts left and right, up and down, that can kind of change, but for the most part, they're in opposite quadrants. So we do have both a vertical and a horizontal asymptote when we do this. The parent function, the vertical asymptote is x equals 0, right here along the y-axis. And the horizontal asymptote is y equals 0, right here along the x-axis. We've talked about asymptotes in the past. Remember, asymptotes are kind of invisible lines, if you will, that the function gets closer and closer and closer to, but it never touches it and it never crosses it. So this will increasingly get closer to the y-axis, but we can go on to infinity and it'll never be 0, okay? Same thing with the horizontal. All right, so let's do example 1. First, we want to graph g of x equals 4 over x. Now, this is the graph of y equals 1 over x. Let me change my screen real quick. So we want to do y equals 4 over x. So if we compare these guys, notice this is a little bit further away from the axis. So if I wanted to draw that, I could draw it, let me get a different color, would be like here and here. Okay, so if I wanted to kind of describe it, disregard this by the way, if I wanted to describe it, I would say that it is stretched away from the axis. Now, at first glance, you might be thinking, well, how are we supposed to know that without graphing it? Well, let's look at this function. Wouldn't you say this is the same thing as y equals 4 times 1 over x? Now, if it helps you to look at it as 4 over 1 times 1 over x, guys, this is just a vertical stretch by a scale factor of 4, right? Y equals 4 times f of x. Okay, so that should make sense. So we're stretching it away from the axis. You can kind of rearrange that as you need to make it make sense. Or if it says graph it with your graphing calculator, do that as well. All right, so example 2, graph g of x equals negative 6 over x. So once again, I'm going to go back to Desmos here. Change this to negative 6. Ooh, that's not what I wanted to do. Negative 6 over x. Okay, so notice we're pulling it away, or we're stretching it away from the axis again, but we also have some reflections here. Okay, so if I go back to my notes screen, the graph looks something like this, and this. Okay, so if I describe that in words, once again, I stretched it away from axis. And then I also have a reflection. Now, some of you are saying, well, did it reflect over the X and the Y axis? The X or the Y axis? Well, we can look at this, guys. If I put this to here and this one to here, that would be a reflection over the Y axis. However, if I want to look at it a different way, and I can say, or maybe I want to say, well, this is reflected here and this is reflected here, it could also be a reflection over the X axis. Okay, so reflection over the X or Y axis. Now, make sure you don't say X and Y axis because that wouldn't be correct, but depending on which way you look, it could be the X axis or the Y axis or the Y axis from which way I just said. All right. Now, this is the last part we're going to do for today. Please do take note on how to do these because we will use it again for part 2. Now we're going to talk about when we have a left or right shift or an up or a down shift. Basically, all that's doing is it's shifting the asymptotes. Okay. So when we do these, the first thing we want to do is we want to draw the asymptotes. Okay. Just like our normal transformations, guys. This is up or down. If it's plus a number, it's up that number. If it's minus a number, it's down that number. And then this, as you should know, is left or right. Now, please remember, we do the opposite. So if it's minus H, you're going right. If it's plus H, you're going left. Okay, and once again, first thing we want to do is draw the asymptotes. We're going to plot a couple points, and then we're going to connect the points to do that. All right. So we want to graph -4 over x plus 2 minus 1. The first thing I'm going to do, guys, is I'm going to put what the normal axis should be. Let's make it here. This is my normal axis. Okay. Now, if I take this normal axis, the first thing I want to do is I want to draw my asymptotes. Now, this right here tells me I'm moving down 1. Okay, so if I'm moving down 1, this is going to be my asymptote because normally my asymptote is the x-axis. Now it's going to be the y equals -1. Okay, so I went down 1. This tells me I'm going to be moving left 2. So if I'm normally along the y-axis, left 2, 1, 2 would be this. And once again, we show asymptotes with dotted lines, not solid lines. All right, so now I'm going to put this into my calculator. Bear with me for a moment. So -4 over x plus 2 minus 1. And now I'm going to plot a couple points, guys. So the easiest thing to do is when you put that into your calculator, go to the table. And you want to do points right around the asymptotes. So I want like 1 in this general vicinity, or a couple in that general vicinity, and then a few in that general vicinity too. So I get, let me see. A point is -4 1, and this is coming straight from my table, guys. Another one is -3, 3, and -5, 1/3. Okay, so if I plot these, 1, 2, 3, 4, 5, and 1/3 would be here. -4 and 1, 1, 2, 3, 4, 1 would be here. And -3, 3, 1, 2, 3, 1, 2, 3. So I like this, and then follow your asymptotes. Here, let me draw that in a different color. Like that. Okay, now I want to plot 3 points down in the bottom right. So I'm going to move rightwards. So I want my x values to get a little more negative. So I have -1, -5. I have 0, -3, and I have 2, -2. So if I come plot here, -1, 1, 2, 3, 4, 5 would be right here. 0, 3. So, oh, 0, -3, sorry. 0, 1, 2, 3 here. And then 2, -2, 1, 2, 1, 2. So this would be like this, and this would continue going towards the asymptotes. So 1, find your asymptotes, left, right, up, down. 2, use your table in your calculator after you put the equation in the y equals and get a minimum of 3 points. Try to get them fairly close to your asymptotes because we know they get closer and closer and closer. So if you do them like extremely, extremely close to your asymptotes, it's not going to help you any. So this is what the graph looks like. Okay, so state the domain and range. Remember, guys, the domain is your x values, the range is your y values. So if we look here, the only thing that our x can't equal is this asymptote. So my domain would be x is everything except x cannot equal -2. And my range then, now I'm talking about my y value, so up and down. Now my y can be everything except, this would go down here. My y can be everything except this right here. So my y is not equal to -1. All right, that's it for today. Please do your homework on big ideas. It should not be difficult, but become a pro at finding these asymptotes like this. Like I said, once again, we'll do it in part 2 of 7.2. Hope you guys have a great one. Hope everything's going good. Please reach out if you have any questions at all.